Hi, welcome back to the breadboard. In this day and age, lots of kids are back to school, teenagers, etc., but they're not really back to school. They're studying from home, trying to make the best they can in the situation that we have. With that in mind, I would imagine a lot of students that are studying electronics at university, college, or upper high school type of things will want to be trying to set up a home lab of some kind. So what I've got and what I'm starting here is a short series of videos to show you some of the kinds of equipment that you can get online for relatively inexpensive costs that will help you do just that. So to start with, some of the most important things that I find I need in the lab are a power supply right here and a multimeter. So I have one of each sent to me from a company called KAIWEETS. I hope I'm pronouncing that correctly, to have a look at for just this type of video to show you what you can get inexpensively. I'll provide links to the online stores where you could buy them for yourselves. Now, I have not turned on these at all. All I've done is taken them out of the shipping packaging that they were sent in. They came packed very, very well. So as I discover it, you will discover it along with me. Let's hope they live up to what the advertising is. So let's start with the digital multimeter. This is the HT118A digital multimeter from KAIWEETS. Nothing really much on the outside of the box except to say that it is Cat3 1000 volt rated and conforms to IEC 61010-1. So anyway, let's open it up and have a look at what we've got. So we've got the manual. We have a couple of AA batteries provided. We have a thermal probe, probably a K-type thermistor on there. And we have a pair of probes for the multimeter. And of course we have the multimeter itself. Let's take this out of its packaging and we'll do the satisfying zoop. There we go. Okay, so ranges on the multimeter. Let's use the specifications, shall we, instead. Okay, so let's just move those aside slightly for a moment. You see what the manual has to say, because it does say right on the front, before using, please read. So we will. Safety instructions. This will be the usual thing. IEC 61010-1 Cat3 1000 volts. This is a designation in case I'll do a separate video, I think, at some point to talk about cat ratings and stuff like that. This is the recommended area that you can use this multimeter at. It does not specify how good the resolution is or anything like that. Just tells you where you can use it. I'll provide a link in the description. Cat3, okay, there's a little bit right here on the cat rating. So Cat2 measurements are suitable for testing and measuring circuits directly connected to power points, sockets, and similarities of low voltage power installations. Now they regard low voltage, not China, but the cat ratings of even 110 volts is relatively low voltage. Cat3 is measurement suitable for testing and measuring circuits connected to the distribution part of low voltage power supplies. So that's where the power has entered the building. You've got a distribution panel. Cat4, which this is not rated for, but I guess they felt, oh, it is actually says Cat4 600 volts on the front of the meter. Measurements are suitable for testing and measuring circuits connected to the power supply of low voltage installations in buildings. So that's going further away. It is certified for Cat2 1000, Category 3 1000 volts and Category 4 600 volts. If you want more information on Cat, go to the link I provided. Okay, we've got function keys along the top. We've got our function knob, selects the different ranges. We've got volts AC/DC with frequency range. We've got millivolts with a frequency measurement as well. We've got pure frequency with duty cycle. ohms, beeper, diode checking, capacitor checking, temperature measurements, microamps with frequency, milliamps with frequency, and amps with frequency, and a NVC live. This is where you can do a check for the cable to see if it's live without actually putting both probes across. I believe it has a sensor on the front of the meter, black's really hard to see, that you could put near power, or you can use one of the probes as well in this case. It's got a flashlight built into it, red and green light. This is to indicate whether it's safe or not for the voltages. LCD display, function keys, function knob, other measurement, input sockets, common input, blah blah blah. So min max for taking readings, the way you want to capture minimum or maximum voltages. Hold, so it just holds the current reading. Auto power off after 15 minutes. High voltage prompt function, when measuring voltages greater than 80 volts, the measuring current is greater than 1 amp. The orange backlight will light up, prompting you to be careful. If you're just using frequency duty cycle on its own, it says you cannot exceed 10 volts. So be aware of that. You could fry the instrument. Already mentioned current up to 10 amps. Did I mention that? No, I didn't. I am now. I mentioned got a current up to amps range, and it goes up to 10 amps. Yeah, thermocouple is definitely a K-type, or at least that's what it says. Accuracy and specifications. So this is not the most accurate multimeter in the world. So accuracy is 0.5% plus or minus the reading. That's more than enough for most electronic things that you're doing for your first multimeter. This is not an expensive multimeter. It's just one that will be great just for having at home for a home lab for students and things. AC voltages, accuracy 0.8%. DC current 1.2%. So if you're measuring 1 amp, it could say 1.01 or 1.012. So that's close enough for most things that you're going to be doing. If you consider that resistors and everything else that you use for circuits are often only going to be 5% accurate anyway, it's about giving you a closer indication of what's going on with the circuit, right? AC current 1.5%, so slightly less accurate. It is a true RMS, I believe, meter. So capacitance 4%, 5% if you're going over 10 millifarads. Frequency 1% plus or minus 3 count. Usually frequency is very accurate. Voltage, let's have a look. Duty 0 to 10 megahertz. It will measure frequency for 0.2 to 10 volts AC. Overload protected at 250. That's more about protecting you. Range 0 to 100 kilohertz. That's for volts. Diode test. Voltage is about 3 volts that it applies to the diode. So it won't test high voltage Zenas or anything. Temperature range -20 to +400. -20 to +1000. And as usual, you shouldn't be using the meter if the battery is indicating low, because it could be giving you a false idea of what's happening on the voltages that you're trying to measure, and you don't want to electrocute yourself. All right, that's a quick scan through the manual. We don't want to see the manual, do we? We want to see the meter. So here it is. No batteries in there yet. On the back side, we've got a balun, little screw holes. You could stick it on a wall or something if you needed to. Looks like we need a single screw to be removed to get in here to change the battery, or to put the batteries in. While we're here, we'll see if we can see in this thing. Guess the balun just comes off on its own. So There's no screws. This is clamshell together probably. So I'm not going to try and pull it apart right now. But we will stick the batteries in. Made in China batteries. High capacity. It says high energy. Sorry, extra heavy duty is what it says. So let's get those in. Okay. So I got something just to stand that up on a little bit. Just to remove some of the glare. Alright, just focus that in. So nice big clear indicators. Let's try the backlight. That's the backlight on. It's not the orange one. Flashlight. Back off. Function. That flipped me to AC measurement. There isn't a separate AC volts measurement. You just pick which one. That's DC with intermittent. And AC on its own with frequency at the top. So yeah, those are the two measurements. You flip between AC or DC. Now if you don't have AC, then you're not going to get a frequency measurement, of course. Right, let's pull the probes out, see what these are like. So they feel quite nice. They feel, I don't know if they are silicone. They may be probably just plastic of some, well, silicones. They don't feel silicone, but they do feel pretty robust. But come with little protectors. So nice thing is that the meter does have, so we can zoom down here a second, protective shroud, so you can't get your fingers to the connections. And on the probes themselves, they have protective here. So if you've got the other end of the probe connected to your circuit under test, maybe there's several hundred volts on there, you can't touch the volts easily. Okay, we've got a couple of things to provide some sources to. I have this beautiful Vichy resistance standard that Vichy actually made for me a few years ago, and they also put it through their calibration lab and measured the resistors very, very precisely for me. For this multimeter, there's no point in even looking at this. This is so accurate. If this is reading spot on for each of these that we think we have, then we're doing pretty darn good. As you can see, this 1 megohm is 1.00000, it's 5 zeros, 7 megohms, right? The 100K is 1, 2, 3, 4, 5 zeros, 1. So extremely, extremely accurate. It's very fortunate to get this from them. So I've also got my precision voltage source that Ian Scott Johnson sells. He also showed how he designed this and things on his YouTube channel. I'll provide a link. This is one of his original versions. It's he has a newer version out now, even better. But this one works just fine, gives out anything up to 10 volts very accurately. So we'll start out with some resistance, shall we? Let's just flip to the resistance range. And just take the covers off. One of the things that changes cat rating, by the way, is whether these covers are installed or not, because it's protection. And so with the covers on, it's cat 3 1000 volt. If you don't have the covers on, you are cat 2 1000 volt. All right. As I said, should be, if you're working in the industry, you need to be aware of those things. So what I'm going to do is I will screw this into the terminal. Just move that across a little bit so you can see. And this is 1 ohm. Now we're only doing 2 terminal measurements, not 4 terminal measurements here, so Now, does this have a, can I drop the range down? Let's put it into beep mode, diode mode. Nope, that's the best it can do. So it's reading pretty accurately. I mean, that is a 1 ohm resistor. So you know, it's plus or minus 1 digit right there. So that's pretty good. Let's move along. By the way, these two terminals are connected together inside so that you can make a full 4-terminal connection. Right, that's reading 1 ohm exactly there. This was reading 1 ohm exactly as well when I had connected it. There. So let's go to 10 ohms. 10.0, that's pretty darn good. 100 ohms. 100.1. Now, the 100 ohm range is 99.99977. So it's reading a fraction high, but well within its specifications. Read the 1K. 1.000. You can't ask for much better than that. And the 1K on here is 1.0000007. So you can't argue with how accurate that is on the resistance range out of the box. Come on. Actually, I'll probably just put these in here now. At these ranges, any contact resistance is not going to make any difference. So 9.99 for the 10K ohm range, and this is actually 9.99 on the 10K range. So the fact that this was reading 9.99 is absolutely correct. So 100K, 99.9, and this is 100 exactly, so it's still only 1 digit out. And the 1 meg is 1.001. And the actual 1 meg is, well, lots of zeros. So again, out of the box, very, very accurate. That's impressive. I did not expect that. So let's put the resistance standard over there for a second, and we'll fire up the Ian's DC voltage meter generator. All right, currently it's outputting by, next to my last one, 50 millivolts. And you can see here, it's reading exactly 50 millivolts. So we're outputting exactly 5 volts. It's reading 5.005, so it's reading within 0.1%. 10 volts. Again, reading within, well, that's reading within 0.1%. So that is pretty good. This is, I haven't done a calibration recently, but it's way more accurate than this is, and it goes to 1, 2, 3, 4, 5, 6 digits of accuracy. When Ian makes these, he puts them on a 8-digit multimeter for calibration. So very, very accurate standard that he uses to calibrate these. Let's go down to 1 volt. Automatically range down to 1. That's reading pretty good. 100 millivolts. So it's reading down to 1 millivolt. It can't read better than, sorry, it can read. I'm on the volts range right now, so I've gone up to 10 volts. It's got another range, so we go to millivolt range and just let it set. I noticed that the LEDs down here were flashing when I change that. I pull this out. When I change range, it's flashing the terminals that are supposed to be used for that range. Let's just keep going. Just a, sorry, slight detour here. Capacitance is these two. Let's go to current. Now it's flashing terminals that are used for that measurement. That's a nice feature. I've never seen that before. We've got amps. It should come up to this top one. And there it is. Very cool. Never seen that. And NCV live line is volts back to millivolts. That's okay. Let's go back to this. So it's a 60,000 count multimeter. Sorry, I said 3.5 digit before, but it's not. It's more than that. You can see here 60,000 is the count. So if I go 0.650, it's gone into overload. So 0.61 might measure. Yeah, so it's allowing a slight overage on the 60,000 count. It's just a little bit. I don't know how far it will go. 0.62. Yeah, 0.61 something something. 0.6190. Yeah, so as soon as it gets to 620 millivolts, it will trip out. So DC voltage seems to be working just fine. So let's move on to something else. I'll grab some capacitors. Unfortunately, I don't have a capacitance standard, so we'll just have to grab some and compare. I do have a LCR meter, so we'll use that as a standard while we're measuring. Okay, so this one is a ceramic capacitor, I believe, 47 nanofarad, and I'm reading close to 42. So completely different range of capacitance. Should be less, and this is reading 41. So this is, yeah, 41.8 versus 41.1. So now they're very, very close to each other. Let's just grab one more different capacitor from in here. I got no idea what this one is. Oh, 8200 picofarads. So 8.2 nanofarads, I think. It's a really old one, so yeah, 8.2, 8.1. So what is this going to read on here? .1, 8.2. So, silly me, let's pick a diode check. That's beeper, that's diode. And you can see the LED is lightly illuminated there, and it's got a 1.6 volt forward drop. Sounds correct now. And flip it the other way and open. So there's diode checking for you. This happens to be a old red LED. Not sure what it's constructed from, but definitely gives us a 1.647 volts forward drop. So if you were trying to figure out what resistor to use, put 20 milliamps through it from a 5 volt supply, there's the start of your equation. So that's good. What else are we going to check with this? All right, what next? Let's have a look at the temperature maybe. So with the kit came a K-type thermocouple. This one doesn't have the usual kind of terminations on the end. It's just got a couple of loose banana plugs here right now. It's in the bed warm, about 25 degrees or so. So let's put this in here. All right, let's go to temperature. And it's in Fahrenheit. At the top is 23, down here it's 73. Here it is, the KAIWEETS digital multimeter, true 6000 count, auto ranging, fast, accurate. Price $44.15 Canadian. So here, this is on Amazon.ca. So obviously it's going to be less in US dollars, probably 39 or $35 US or something like that. Can I find out here? Yeah, so in US dollars, $35, $35.99. So very good. Seems to be very good value for money, because the meters that I had surrounding this, which I use often, these orange ones, these are Keysight Agilent, formerly HP, and these meters are about $500 each. So they're 10 times the price of this. Now they do have an extra digit. This is 1, 2, 3, 4, 5. I think it's about 50,000 count or something on these. This is a 6,000 count. So, you know, you've got extra accuracy in things. But for a home lab, for a student learning electronics, something like this would be perfectly adequate, and it would make a great Christmas present or something if you have somebody that you'd want to help support in that way. So that's good. Yeah, anyway, so far I've no reason to not recommend this meter. It seems to meet all of the criteria. There's one thing I do want to check before we conclude the video though, and that is inside it, what kind of fuse does it have? It needs to have a decent fuse in it for protection of the user. So we will have a look. It says it's got a 600 milliamp fuse and a separate 10 amp fuse, which is good because that means that the milliamp range as well as the amp range are both protected separately with a fuse. How accessible the fuse is, I guess we'll find that out now. So I don't see the fuse here. It's certainly not under the battery. Oh, the meter has a little booty on it. There we go. So there's the booty. Does it say what it's made out of? Feels like a TPU or something. 1, 2, 3, 4 screws. Okay. I'll take a moment to get inside. We should get a millivolt reading of sorts. Alright. The screws are not captive, so be aware of that, and they're threading into plastic. For the price of the meter, that's, I guess, okay. Batteries connect by a couple of little spring clips. Everything is done by this little chip up here. Zoom in a little bit. So we do have HRC fuses. They're not like you get in a Fluke or an Agilent or something like that, but they are ceramic fuses, so that's a lot better than a lot of multimeters. Input protection, we've got a couple of MOVs here. Oops, move up a little bit. See if I can zoom in a tad just so you can see better. So main inputs here. I guess there's a bunch of components on the other side. We've got some input diode protection here for the unit, couple of MOVs. More input protection resistors here. Most of the work is done up top. Obviously the two fuses. Okay, not sure how well this is going to go back together again. Separating the zebra stripes from the display at the same time as well. Didn't quite want to do that, but hopefully it's good enough alignment. It'll all go back together nicely. Well, there's absolutely nothing on the other side, which is interesting. We have some surface mount LEDs down here. These are what will be illuminating via a little light pipe the meter connections for the depending on the range that you've selected. Zebra stripe for the display. We have an antenna here for the high voltage sensing. Beeper. The main chip. I don't see a massive voltage divider. We have a resistor here for the current. It's a 5 milliohm. That's probably doing the 10 amp range. Yeah, it's going through the 10 amp fuse down to here. and I'm trying to find out, see if there's a big, yeah, they must be just using these resistors here for the, when you're measuring high voltages to bring them down. There's definitely no user serviceable parts in here for sure, except for the fuses. That's about it. So let's see if we can squeeze this back together again. So I would probably be a little bit reluctant using this on any industrial site with industrial kind of power and volts and things, because it does have some protection and it's more than enough for everything after a socket. But if you go back and look at my videos where I've torn apart these adjuvants and things like that, you'll see a massive difference. Now, this is not an unfair judgment, and it's not really a criticism, because there is a massive difference in the price as well. And if you're just setting up a home lab, you're not really going to be doing that kind of experiment, so that's okay. This would still be perfectly adequate for that type of work. I think once you graduate or you get out into the field, then your company or you, depending on the arrangements, would invest in even higher end equipment that provides you more protection as well as protecting itself. But this does seem to have all the basics in it that it needs. It's a shame you have to take the whole lid off just to get to the fuse, but again, all that comes at a price. So let's just get this back together. Let's make sure it still works, and I have one more test to try. So the last thing we want to check on this is for now, is the NCV, which is the live power testing. So what I have here is a 110 volt AC line cord that is plugged in, is powered, but obviously I'm not plugged in into an appliance. If I just put it near the sensor at the end here, you can see it will tell me it's green it's detecting an AC voltage, but it's lowish. And if I go close enough, it'll tell me it's high voltage. Okay, now you can also do this using a probe. Only put one probe in, not more than one when you're doing this, and you can actually probe in the sockets, and there you go, it's telling you that that one is live. Okay, so easy way to check sockets for which one's live, see if they're wired up properly and things like that. As I said, use mains testers in that manner carefully, because you don't want to have your other probes in, because if you had your negative in, potentially you could have mains voltage coming out of there as well. I mean, albeit it's going to be through 10 megohms resistance or more probably, which is the standard load resistance of multimeters and things, but it could still technically give you a tingle. So when you're doing this kind of probing, don't have other cables in. I think that's pretty much everything except for the current ranges, which as I said, we will test in a separate video when we're looking at the DC power supply and things like that. So let's call it a wrap for this. Would I recommend this for a little home lab for students, and whether they're college, university, or even just as a hobby meter? Seems to do the job. Seems to be quite accurate. It's way better than what the advertised specifications are. It comes with a rubber booty. It's got all the major features that you could ask for. Capacitance on the high microfarad ranges, or I don't know why it's reading different to my LCR meter there. But obviously the lower values, picofarads, nanofarads, they all lined with what the LCR meter said very, very closely. So every other range we've tested so far has been perfectly adequate and perfectly within specifications. So that's good. For a $35 US multimeter, it seems to be quite a good bargain. I will use it for some of my experiments going forward, and we'll see how it fares. That's it for now. If you liked the video, give it a thumbs up. If you didn't, well then don't. And I'll see you in the next one. Next coming up will be the bench switching power supply. Bye for now. Just as a quick sanity check, what I did was I've rigged up my main supply. It's going into the sense input of the KAIWEETS HT118A. I've got the negative in my hand here, and that's going through. I'm going to measure it from here, and then the negative of my multimeter here is going to the neutral. As you can see, I'm getting 5 volts reading, that's it. And if I take that out of the live, so there's enough leakage through it to put 5 volts out, which is not enough to hurt you. But it does tell me that there is some kind of leakage coming through here. Could be because of the mobs or whatever. Reinforces the fact that when you're doing a mains check, have the other cable out. And just to show you, this does have 124 volts on it. And because my cables are running near here, it's picking up on that. Okay, good little tester. Alright, see you in the next video.